The sound guy is here again with lesson 3. I hope that you have learned from lesson 1 and 2. So today I'm going to take you through how to operate an audio mixer. I'll start with analog and then we go on improving to a digital mixer. Welcome to today's class. Yeah, so this is the mixer that we are going to learn today. It's a 16 channel mixer. So it's the Yamaha AMG 166CX USB mixer. USB means that you can use it as an audio interface or a sound card. Yeah, so this has 16 inputs and also several outputs. I'm going to take you through signal flow from the input all the way through the mixer and what every button does and until the signal flows out of the mixer. So to start with the inputs, we see here there's mic inputs from mic 1 to mic 12, and for it being mic inputs, it doesn't mean that the signal has to come from a microphone, but it means that the level of that signal in terms of decibel must be at mic level. And then we have the line inputs, which uses the standard jack, and that means, as the name says, line inputs, it means the level of audio that you are inserting here, it must be at a line level. So therefore it's very important for you to understand whether your signal comes from an instrument or a device that gives you mic level or line level, so that you know where to insert it. Then the next thing here we have is the insert connector, and this is used in most cases where you have maybe an external effect, where you can take the signal that you have inserted here, you take it out using the jack, audio jack, to the effects processor, and then come back through the same cable and then continues to the channel. This applies where you want to have a specific effect on each and every channel, and maybe you have that effects box that you can connect with. So the next thing here is the trim, or what we call as gain, and it's coded white. The other name we give this is the preamp. And what happens to these preamps is that some signal level, especially for microphone, are very low. Therefore you need to amplify it a little bit so that it can be on a level that cannot be operated on a mixer. So therefore this is the first way that we amplify our signal, so that we can be able to bring it to a level that you can operate it on a mixer. So it is very important to understand your signal source and understand how loud is it, and in terms of decibels, so that you know whether you need to reduce the level or to increase the level to avoid distortion from the source. Always make sure you use the light gain to avoid distortion in your audio processing. So remember that good mixing will start from the source. From the source, it means from the singer. If you have a good singer, you will always have good audio signal. And then if you are able to control your gain and to control the level of your audio signal, you have better mixing. It's very important for you to make sure that the gain that you are having, or that you are setting for your audio input, whether from a line level input or mic level input, it is optimum, which means it is enough for your signal processing. Avoid too loud signals to avoid peaking and creeping, and also try not having too low signals from the source. The next thing here we get to see is the high pass filter, and what high pass filter means is it passes the high frequencies and then cut the low frequencies. So in this mixer, I can see that the manufacturer had decided that the high pass filter is at 80 Hz, which means if I engage the high pass filter, any frequency that is below 80 Hz will not be allowed to pass through that channel. So a high pass filter we apply in most cases, like in vocals or in vocals, and where you don't need the low end frequencies, so you can apply the high pass filter. So in analog there's a limitation of low pass filter, where because you'll find that the manufacturer has decided a specific low pass filter, but in digital you'll find that you have the ability to change the low pass filter and to determine which frequency do you want to be your cutoff frequency. So that's what that button does. So in this mixer, when I engage that 80 Hz, it means that anything that is lower than 80 Hz will not pass through that channel. So the next thing, the next knob that we see here is the compressor, and this one, it's a compressor helps you to maintain the level of that signal at a specific level, where if you have someone shouting on the microphone, you are able to maintain or to compensate the shouting by bringing the level a bit lower with some few decibels, and then if someone is not projecting the voice enough when they are singing or speaking, the compressor will help you to raise the level to the desired level that you have selected. A compressor, it's like automatic gain, where it helps you to maintain a specific gain of your input. When someone lowers their volume, you don't have to keep on adjusting the gain in the process. So it helps you to just just keep the gain or the signal at the same level. So here we have the equalizers, and this type of equalizer we call them parametric equalizer. Means that you have specific frequency to deal with, and you have to decide which frequency do you want to cut and to boost. So in this case, I have the knob that controls the high frequency, the mid frequency, and then the low frequency. So in this case, I'm able to control 3 frequencies. With high frequencies, you are given a range of decibels level, where you can cut the specific frequency, the specific high frequencies, that is, cut it by, or boost it by 15 decibels, or just remain the way it is when the knob points at the 12 o'clock. And then for the mid frequencies, you have the ability to cut or boost any frequency that you select, from 250 Hz to 5 kilohertz. And then when you select a specific frequency, let's say for here I select 250 K, I can boost by negative 15 by I can boost by 15 decibels, or I can cut by negative 15 decibels. And then when there's a center, it means I'm not cutting or boosting any frequency. Then we have the low frequency. You find most of the Yamaha analog mixer giving you 100 Hz to operate as the low frequency. You are boosting or cutting 100 Hz by 15 or by negative 15 decibels. So I find analog mixer limiting someone to select the frequencies, because you see in this case they have already selected for you the low frequency that you can cut or boost. Also for the high frequency, they have already selected for you, so you don't have the ability to choose which one do you want to cut. And also for the mid frequency, they are only given a range between 250 to 5K. And now let's say, for example, if the high frequency that you can cut is 8K, so in case you want to cut 7K, it's impossible because it's not within that range. But the good thing with digital mixer is that you can be able to select the frequencies that you want to cut, and they provide you even up to 5 frequencies that you can be able to select and cut or boost them. So that's all about analog parametric equalizer in this mixer. So here we have the auxiliary. So the auxiliary just means additional outputs. So in this mixer we have the auxiliary bus, where you can connect, you can use it as your output. And what this knob does, it helps you to send this channel to that specific auxiliary bus. Like for example, if I want to send this channel to auxiliary 1 bus, I will just use this knob, and I have a capability of sending from 0 to 10 decibels of that channel. So I'll just increase that, and then that channel will go to the auxiliary 1 bus. The same case to auxiliary 2. But below there we have a button that is it is labeled pre. So when I press the pre button, the level of this channel to that auxiliary bus is independent, such that it only depends with this knob. But when it is out, it means that the level of that auxiliary bus from this channel depend on the level of this fader. So when I'm increasing the level on this knob, I'm taking the output of this fader. So when that volume is at 0, it's at 0 in reference with this fader. What happened is that when I increase, I'm increasing the output of that fader. So it means if I increase the level of this fader, you will find that there is a change in that auxiliary bus. But when it is engaged, it means it is independent. This fader doesn't matter to the auxiliary.